we have done one image manipulation program, and that was mostly, well, for the light and fluffy of the world. Um, what we would like to do is actually do some math and do some computations on the file. So what we are going to do is load NumPy. And I am going to load all of the mathematical functions available in NumPy. Then I'm also going to load PyPlot and SciPy ND image, and then the entire image input output package. All right, and so I am going to read in that photo. Now it's the same photo we were working with if you watched the last video. It's 3.jpg, right? But now I'm using the image input output routine, reading in the image, right, and storing it in that photo variable. Now what I'm going to do is, instead of using the show, right, photo.show, right, from last time, which was the Python image image library, I'm going to use the PyPlot, right, and I'm going to plot this thing, right, and I'm going to do it in grayscale, right, and then unfortunately what I also have to do is I have to plot the figure, right. I have to tell it what to do and how to configure it, and then I have to tell it to put it out there. Now up in the right hand corner here, notice that the Variable Explorer also has a section where it says plots. We're not going to get a separate window with the images in it anymore. You're going to have to flip back and forth between the Variable Explorer and the plots window part of this when we do this. Then it's going to be the average value for the image. Grayscale images, whether you know it or not, all run from 0 to 255 in integers. So everything that you see is a 0 to 255 grayscale value. Even if you have an RGB, what you have is you have three separate files. You have a red, a green, and a blue channel, and they're all 0 to 255. They're all just gray. And then it takes the red one, makes everything a shade of red from 0 to 255. Everything green, 0 to 255. Blue, 0 to 255. It stacks them on top of each other, and that's how you get nice, pretty color pictures out of everything. You notice that we will have, it'll look a little graphic, as in graphical. It'll actually have an axis on it because that's what plot does. It's trying to mathematically plot out this thing. It doesn't care that it's an image. It's an array of numbers, and so it just does it. And so we can take off the axis and plot that thing. Then you get the average, the max, and the min. That should be 0 and 255, not surprisingly. And then, if we want to smooth the intensity variations, we can use a bilinear interpolation fit to this thing. It's math, right? Don't get hung up on the terminology. If you go to the documentation for Mathplot and PyPlot, it'll tell you what all these various things are. You can also do nearest neighbor interpolation to figure out what it is, to do variations in intensity. And then we are going to put a mask over the image. So we are going to do a circular mask, and then crop the image inside the circular mask, and then this last one will do something funky. This one I am not, because I can scroll up and down in the output box. I don't need to use the cells function. I can just run the program straight out, and it will run the entire thing. you will see the variables appear over here. Right? You will see them as arrays, right, as they come up. Right? We now have the image. Right? Notice that crop photo, D, right, again they are in alphabetical order, not in the order in which we did it. We loaded photo first. That is an array of 8-bit values. Right? Then crop photo is the same. Right? D, right, is an integer. F turns out to be an array. Right? Your LX and LY, that's for the scale of this thing, right, to figure out the mask size. Right? And then that mask is an array of Boolean values, which is interesting. Because what you want to do is anything which is inside the mask turns true, everything which is outside the mask is false, right? And everything outside the mask goes to zeros when you do this. Notice that the average value in the image is 148 point. It gives you a floating point value, because it averages every single value in the image. But its max and min are 255 and 0, just as it should be. We really want to take a look at the output. And there we have images. Notice that the first one that we did, which was plot image show, it tells you that 0, 0 is the upper left hand corner. And you have increasing y going downward, increasing x going to the right. If you would like to save that image, notice that you have this icon up in the left hand corner. It says save plot as. It will export the thing as a PNG or as a JPEG file, depending on your version of Spider. My version of Spider is a little bit on the old side. I haven't updated Anaconda in a while. And so mine will just go out as. I can save every single one of the plots, every single thing that we've just created, all at one shot. And it will do consecutive file names for me. And then I can delete everything, and I can remove one plot at a time, or I can remove them all at once. It's showing it at 85% of its original size. I could type in 100, but then I would have to scroll all over the place. So anyway, that's just the original photo. Dr. Sarah Harry. And 0, 0 in upper left, going down to a little bit over 1400 and the Y, and a little bit over 2000, almost 3000 in the X. The next one, that's this piece over here, plot figure. And then I want to remove the graph look, so I want to take off the axes. And it looks like I just put out a picture. No big thing. Here I want to do a bilinear interpolation, but only on this section of the photo, which is, it turns out to be a piece of his scarf. And notice that I can blow it up. And it gives me a 50 by 50, because it goes 500 to 550 in both directions. They don't have to be square. I could make this rectangular if I wanted to. So this just gives me the ability to pick out fine grain detail. This is nearest neighbor. Notice that nearest neighbor is a little bit more pixelated. You use bilinear interpolation or nearest neighbor interpolation on particular images, sections of images, depending on what you're trying to pull out of the image and what you're trying to do as an analysis. If you are working for the government and you're trying to pull out imagery and see whether or not this is a camouflaged gun emplacement, or troop emplacement, or fuel depot, you might use bilinear, or you might use nearest neighbor. right? Or you might use something way, way, way more advanced. All right, I'm just giving you the sort of a basic feel for, what this can do and what you have at your disposal. All right, now this thing, all right, LX, LY, all right, D is equal to the photo shape. All right, so if I go back to this, D is an integer, right, and the value is 3. Right, so this tells me the shape of the photo. Right, LX and LY are also getting a photo shape. Right, this is giving me the length in the X and the length in the Y. Right, 1463 and 2197. Right, so here we go. Now I'm going to take and create a mask. Right, I want to take half of X. Right, subtract it from the X value, square it. I want to take half of the max Y value, subtract it from Y, square it. Right. Right. And as long as, and that thing has to be greater than LX times LY divided by 4. All right. That number I'm going to set to 0. All right. And then I'm going to leave everything else alone. What that gives me is that. So it gives me a value at that circle in the center, right? Dead center on the image with a particular radius. That's the square plus the square, right? That's r squared is equal to x squared plus y squared, kind of thing. I just, restricted how far out it went, right, in R for the radius. All right, and then everything outside of that went 0. Everything inside of that, right, I left alone. And so this gives me my nice funky little mask. I can now crop that. Once I change this, by the way, once I have done this, right, the file has been, the file in memory, right, has been altered. If I want the original file back, I got to reload 3.jpg. Now, if I crop the masked image, that's what I get. Right, and I cropped it at the center. Right, with this crop photo. Right, and I just did it in terms of X and Y locations. So basically I shifted everything. The center of the photo is 0, 0, and I just went positive X, positive Y, negative Y, and chopped it out. And then this last one, flip up. So it takes photo, which is now the alternate file with the mask on it, and it's going to flip it up. Flips it upside down. So it does a total flip up. You can also do a flip left and a flip right. If that sounds very, very familiar, again, that's tools which are available to you, right, inside of iPhoto or any other image manipulation program. So we have one more to do, all right, and that's image manipulation 3.